All right, so here should be the last video to kind of help you through this. Okay. Um, Yesterday we were talking about find height two. Find your heights here and your distances. Take your second height and divide by your first height and figure out what that ratio is, and then take your distance, divide, and you notice you don't get the same thing. All right. Now, the reason why not is because when we come down here, right, these two heights, right, height two to height one, what ends up happening is they are equal to what you would get for the distance squared over the distance squared, not just the distance divided by the distance, right? So what you see here is that these two things are proportional to each other this way. And so what ends up happening is when you take h2 over h1, and let's say that this is 2 times bigger, so you get 2, right? Now, the thing is, when you take d2 over d1, like I told you to do yesterday, you got to keep in mind that, remember, d is going in for v, and v is squared. So to get these to be equal, remember, these have to be squared. So to find the ratio of d2 to d1, we'd have to take the square root of that, and we'd have to take the square root of this. So if h2 to h1 is 2, then d2 to d1 should be the square root of 2. So the best ratio that you can do here, all right, the best ratio you could do is if you took height 2 to height 1 and got 4. And the reason for that is when then you calculated your d2 to d1, you should get 2. And the reason for that is because the square root of 4 is 2. And so this is what I was talking about when you look at the equations. So we go up and look at these equations, right? Where k is equal to 1/2 mv squared. And remember for our purposes, we can basically just call that d, right? And where that's just mgh. This is not squared, this is squared. So what ends up happening when we look at the ratio of height to height, we have to square root that so that we can get the same meaning. So what we did here, I showed you right here, is we took mgh2 equals 1/2 mv2 squared, and when we just divided by mgh1 and 1/2 mv1 squared, all those things canceled. And we were left with this relationship right here. We were left with this relationship, right? Where h2 over h1 equals v2 squared over v1 squared. So to find the relationship of v2 over v1, we'd have to square root both sides. We'd have to square root h2 over h1. Now remember, we're using d in for velocity, so it'd be d2 over d1 would be the square root of h2 over h1. Or if you don't like the square root part, the other way, you could just leave it the way it is right there. And if we just leave it the way it is right there, you could get this, where h2 over h1 is equal to d2 squared over d1 squared. Or the same relationship is the square root of H2 over H1 equals D2 over D1. So now you have that relationship. You should have that relationship, that mathematical relationship, that you should be able to write your conclusion and show, like, mathematically, yes, okay, it does stay the same. So when we increase the height by a factor of 4, we will increase the distance by the square root of that. So that would be a factor of 2. All right, so we go twice as far if we raise the height 4. And the math bears that out, that shows that energy actually is conserved, because that's what the mathematical equations say they're going to do. Okay. Now hopefully this helps put the finishing touches on your lab. What I want you to do is just write everything up on your lab paper, right? Submit, and then turn that in. Make sure it has a good description. Make sure you have data. Use your data to show that relationship. Okay. So find the relationship in your data and show. Now, keep in mind, you're working in the real world. It's not going to be perfect. Okay. If you have your height 2 is 40 centimeters, your height 1 was 10 centimeters, so that's 4 times higher, and the distance isn't quite exactly 2 times. It should be close, though. All right, it should be close. So understand that we're working in the real world. We have to deal with things like friction on the track, the way that the ball rolls down the track. It doesn't quite get to keep all of its energy because there's some friction and some things like that it just doesn't, it's not perfect. Okay. Also, we have to assume that the tables are perfectly level, the floor is perfectly level. And unfortunately, that's just not true. Those tables aren't perfectly level. The floor is not perfectly level. So again, you should be close. All right, your data should be close, and that's fine. Now, if we were doing this in a real laboratory setting, we would make sure all of those things were taken care of. But like I said, you should get the data well enough. You should have data that's good enough that you can show either this relationship here or this relationship here. Okay, and it should be evident in the way you write it up. Again, if you have any questions, let me know. But I think you should be able to finish everything today. And then when you're done finishing that, just go ahead and start reviewing and getting ready for the end of the unit. All right. Talk to you later.